Welcome everyone. Through this video, I am going to discuss today the straight line in three-dimensional geometry. I will discuss different form of straight line, angle between two straight line, intersection of two straight line, shortest distance between two straight lines, and condition of coplanarity of two straight lines. So before we start, we recapitulate the formula of straight line. So look, straight line, equation of line passing through A vector and parallel to B vector. This is expressed as R equals to A plus lambda B. So passing through A vector and parallel to B, R equals to A plus lambda B, while lambda is any scalar. And if we express it in terms of Cartesian coordinate geometry, that is in terms of x, y, z, then its equation will be x minus x1 by A, y minus y1 by B, z minus z1 by C. That is, it passes through capital A, x1, y1, z1. In vector it is small a vector, position vector. So it passes through capital A and parallel to a line, parallel to a vector whose d ratios A, B, C. So this is equation of line in Cartesian form. So A, B, C are d ratios. This is called symmetric form, standard form of straight line in Cartesian coordinate geometry. So write a 1 marks problem of board exam. Find d ratios of the line represented by 2x minus 1 by 2, y minus 2 by 3, 3z minus 2 by 2. So look, our standard form, coefficient of x is 1, y is 1, z is 1. So it is not in standard form. So standard form is x minus half by 1, taking 2 common. So this one is in standard form. And now this is z minus 2 by 3 by 2 by 3. Dividing it by 3, we get this. Now d ratios are 1, 3, 2 by 3. And you may simplify it by multiplying 3. So this is y minus 2 by 9, z minus 2 by 3 by 2. So what is d ratios? D ratios is 3, 9, 2. 3, 9, 2. So listen, this to be noted that to find d ratios you have to put in standard form. Also the line passes through half, 2, 2 by 3. So this is basic concept. Now one more problem. So sometimes it is given in twisted form. So find d ratios of the line. Find d ratios of the line 2x minus 1 by 2, 3y minus 1 by 3, z equals to 1. Now this is not in standard form. Our main aim will be to put in standard form. So in this case, we write this equation in this form. So without changing meaning, we can write it in this form, z minus 1 by 0. If it is in comma form, then we write it as z minus 1 by 0. Now look, if we consider the first two, we get this one. If we consider first or third, look, 0 into 0, you get z equals to 0. If you consider first and third, you get z equals to 1. So now put it standard form, x minus half by 1, y minus 1 by 3 by 1, z minus 1 by 0. So D ratio is 1, 1, 0. 1, 1, 0. So this is equation of line passing through 2 points and 2 basic problems of board exam. Now second form. Now equation of line passing through 2 points. R vector equals to A plus lambda into B minus A. This is vector equation of line passing through A vector and B vector. So Cartesian form, x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. So it passes through 2 points, x1, y1, z1 and b, x2, y2, z2. Now look, in formula number 1, in terms of D ratio, this is x minus x1 by A. So you know, if it passes through 2 points, then D ratio is difference of coordinates. So A is replaced by x2 minus x1, B is y2 minus y1, C is z2 minus z1. So this is equation of line passing through 2 points. Next, number 3. So next basic theory, angle between two lines. Angle between two lines. R vector equals to A1 plus lambda B1 and R vector equals to A2 plus mu B2. So passing through A1 parallel to B1, passing through A2 parallel to B2. That is, angle between the lines is the angle between, one is parallel to B1, another is parallel to B2. So angle between them is angle between B1 and B2. So angle between lines is the angle between B1 and B2. Therefore, cos theta equals to, we know from dot product, B1 dot B2 mod B1 mod B2. So if two lines are perpendicular, then we know B1 dot B2 equals to 0. So this is, you know, all of you know it, well known property of vector. Now if equations are given in Cartesian form, this is symmetric form, x minus x1, y minus y1 by b1, z minus z1 by c1. Passing through x1, y and z1 parallel to this, and x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. So they are similar like b1 dot b2 means a1 a2 b1 b2 c1 c2. So angle between them is cos theta equals to b1 dot b2, that is a1 a2 b1 b2 c1 c2 by root over a1 square b1 square c1 square into a2 square b2 square c2 square. So if angle between them is 90 degree, then cos theta equals to 0. So what is condition of perpendicularity? A1 a2 b1 b2 C1 C2 equals to 0. So this is most important result. Two lines are perpendicular if A1 A2 plus B1 B2 plus C1 C2 equals to 0. Next theory. So intersection of two lines. Intersection of two lines. Intersection of two lines. Suppose these are 1 and 2 are two lines and we want to get point of intersection. I am saying only the steps. So if we take this as lambda, then we get a point on the line 1. So what is the point? X equals to x1 plus lambda a1, y equals to y1 plus lambda b1, z equals to z1 plus lambda c1. So this is a point. Many points, so one point is this. So putting value of x, y, z to the second equation, we get a relation. So from this relation, from considering first and second, you have to find lambda, and second and third, you have to find lambda. If we get same lambda in each case, then we say that two lines intersect. Otherwise, they do not intersect. If we get same value, putting value of lambda, we get point of intersection. Now, shortest distance between two skew lines. So R equals to A1 plus lambda B1. R equals to A2 plus mu B2. So skew line, suppose this is L1, this is L2. Two lines are said to be skew if they are neither parallel nor intersecting. That is, they do not lie in a plane, because in a plane two lines either parallel or intersecting. So they are different plane. So L1 and L2 in different plane. It is not possible to show this one. Suppose L1 and L2 are two lines in different plane, and PQ is line of shortest distance. Then PQ is perpendicular to both the lines. So what is skew line? If two lines are neither intersecting nor parallel, then they are said to be skew line. That is, they lie on different plane. So line of shortest distance is perpendicular to both the lines. And formula of shortest distance, mod PQ equals to A2 minus A1 dot B1 cross B2 by magnitude of B1 cross B2 and total mod. So you have to recall this formula. If PQ equals to 0, that is shortest distance equals to 0, shortest distance is 0, then two lines intersect, means they lie in same plane. That is, two lines intersect. If two lines intersect, so they must be coplanar. They are coplanar. So look, we are getting formula of shortest distance. If shortest distance equals to 0, then two lines intersect. If two lines intersect, then they are coplanar. So coplanarity, so condition of coplanarity in vector form A2 minus A1 dot B1 cross B2. This is condition of coplanarity of two lines. Now, in terms of Cartesian coordinate, what will be our result? So line will be x minus x1 by a1, y minus y1 by b1, z minus z1 by c1, x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. So formula of shortest distance. So a2 minus a1, that is x2 minus x1, y2 minus y1, z2 minus z1. Then that is scalar triple product. a2 minus a1 dot b1 cross b2. So this is scalar triple product. This means determinant. So determinant. So a2 minus a1, x2 minus x1, y2 minus 1, z2 minus z1. Now what is b1? b1 is d ratios, a1, b1, c1. So a1, b1, c1. This is a2, b2, c2. Then its determinant. By mod b1 cross b2. Now b1 cross b2 mod is root over. So b1 c2, method of cross multiplication, b2 c1 whole square plus a2 c1 minus c2 a1 whole square plus b1 c2 minus b2 c1 whole square. So this is formula of shortest distance in terms of Cartesian coordinate. Now if shortest distance equals to 0, then determinant this equals to 0. So x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. This equals to 0. That is shortest distance 0. That is lines are intersecting. So condition of coplanarity is in terms of Cartesian shortest distance. That is determinant this equals to 0. And finally, shortest distance between two parallel lines r equals to a1 plus lambda b and r equals to a2 plus mu b. So two lines are parallel. Then shortest distance equals to a2 minus a1 cross b by magnitude of b. So this is formula of shortest distance of two parallel straight lines. So these are the working tools of this chapter. Now we solve problems of straight lines. So 1 to 9, they are problems of same type to find foot of perpendicular, image and perpendicular distance. So we have already discussed in previous video how to find foot of perpendicular and perpendicular distance by shortcut method. Here we use today the general one. Now look, a line is given and we have to find foot of perpendicular from minus a to the given line to the given line. So this is a, this is m. Suppose line is PQ. So this is called foot of perpendicular. So what will be our steps? So PQ is given. So we know D ratios of PQ. So what is D ratios? 1, 4, 9. Now A is fixed and M is a point on the line 1. So we have already discussed, to get any general point we take this as lambda. So what we are getting, x equals to lambda minus 5, y equals to 4 lambda minus 3. So z equals to 9 lambda plus 6. So what is coordinate of m? Lambda minus 5, 4 lambda minus 3 and 9 lambda plus 6. For different values of lambda we get m. So m is this. So now a is known, m is known. So we can find D ratios of am. D ratios of am, that is difference of coordinate is d ratio. So lambda minus 5, lambda minus 5 minus 2, so lambda minus 7, 4 lambda minus 3 minus 4, so 4 lambda minus 7, 9 lambda plus 6, 9 lambda plus 7. So d ratios of AB, now PQ 1, 4, 9. So AM perpendicular to PQ. Therefore 1 into lambda minus 7, 4 into 4 lambda minus 7, 9 into 9 lambda plus 7 equals to 0. A1, A2, B1, B2, C1, C2. So 16 lambda, 17, 17 and 81. So 98 lambda. So 7 plus 28 plus 63. So 70, 98. So lambda equals to 1. So if you get lambda, then putting value of lambda we get m. So coordinate of m, 1 minus 5, so minus 4, 4 lambda minus 3, so 4 minus 3, 1, and 9 plus 6, this is 9 lambda, so 9 plus 6, 15. So we get foot of perpendicular. So if we want to get image, then Q, then we know M, we know P, Q alpha beta, gamma is image, so M is midpoint, we get coordinate of image. So if you calculate AM, distance AM, so this is distance of A from the line PQ. So three types of problem: foot of perpendicular, perpendicular distance, and image. Sorry, hello. So process is same, but to our problem, the foot of perpendicular from 2, 4, minus 1 to the line, this is minus 1, this is minus 9. To this problem, this 9 will be replaced by minus 9. So D ratio is minus 1, 4, 9, minus 9. So this is minus 9 lambda plus 6, minus 9 lambda. So this one is difference. So this is minus 9 lambda plus 7. So others are, this is 1, 4, minus 9. So AM perpendicular to PQ. So 1 into this, 4, this one is unchanged. Then minus 9 into minus 9 lambda plus 7. So 81 plus 16 plus lambda, 98. Now 7 plus 28. Look, this is minus 63. When it is to the right hand side, plus 63. Otherwise, this is not, this will be minus lambda, minus 63. So this one is minus 9. So we get lambda. What is lambda? Lambda equals to 1. So putting value of m, putting value of lambda in 1. So this is minus 4, this is 1. So minus 9 plus 6. So this is minus 3. So foot of perpendicular is minus 4, 1, 6. So modification, this is 9 is replaced by minus 9. So this is most important problem for both. Now we consider some same types of problem. So from description table, you look, the problem numbers 3, 4, 5, 6, 7, 8, 10. They are of same type. Same concept we need. So consider problem number 6. So the lines L1, x1 equals to 5, y by 3 minus alpha, z by minus 2. L2, x equals to alpha, y by minus 1, z by 2 minus alpha. Are coplanar. The alpha can take value 1, 2, 3, 4. So coplanar, that is shortest distance is 0. So this is our working group. First we have to express the line in standard form. So we have already discussed this type of problem, how to find standard form. If it is 5, x equals to 5. So x minus 5 by 0 equals to y by 3 minus alpha, z by minus 2. And second one, L2, x minus alpha by 0, y by minus 1, z by 2 minus alpha. So they are coplanar. So what is x1? y1, z1 equals to 5, 0, 0. x2, y2, z2 alpha 0, 0. And a1, b1, c1 d ratios of the lines a2, b2, c2. So 0, minus 1, 2 minus 1. So two lines are coplanar. Therefore, condition is x2 minus x1, y2 minus y1, z2 minus z1. Then alpha 0, 3 minus alpha. So write the formula first. A1, B1, C1, A2, B2, C2 equals to 0. Now putting the value x2 minus x1. So alpha minus 5, 0, 0. So 0, 3 minus alpha, minus 2, 0, minus 1, 2 minus alpha equals to 0. Now expanding we get. So alpha minus 5, this is 3 minus alpha into 2 minus alpha. This cross multiplication, so minus 2 equals to 0. So alpha minus 5, so alpha square minus 5 alpha plus 6 minus 2 equals to 0. So alpha minus 5 alpha square minus 5 alpha plus 4 equals to 0. So factorizing we get alpha minus 1, alpha minus 4 equals to 0. So alpha equals to 1, 4, 5. So look at the answer. Alpha equals to 1. This is correct. 4 also correct. 5 also correct. But 5 is not given. So this is multiple choice question. So look it again. This L1 and L2 are not in standard form. So put them in standard form. Then they are coplanar. So shortest distance equals to 0. So this equals to 0. Simplifying, we get this. Now we consider problem number 4. Shortest distance between the line x minus 1 by alpha, y plus 1 by minus 1 and z by 1 and this x plus y plus z plus 1 equals to 0 and this is 1 by root 3. Then a value of alpha is this. So shortest distance, we need two lines. So one line is directly given, this one. This is directly given. So this is 1. And these are equation of plane. We know two intersecting plane, suppose two wall, they meet in a line. So from these two planes, we have to find equation of line. So take x equals to 0. Then this reduces to y plus z plus 1 equals to 0 and 2x minus y plus z plus 3 equals to 0. So solving 2z plus 4 equals to 0. So z equals to minus 2. If z equals to minus 2, so y minus 2 plus 1 equals to 0, y equals to 1. So point 0, 1, minus 2. 0, 1, minus 2 is a point on the line. So we are getting the point. Now you have to find d ratios of the line. Now line is perpendicular to the normal of both planes. So let A, B, C be d ratios of line. Therefore, 1 into A, 1 into B, 1 into C equals to 0. And this is 2A minus B, 1 into B plus 1 into C equals to 0. So, by method of cross multiplication, A, B, C. So, A 1 into 1. So, this is A by 2. B. So, 2 minus 1. This is 1. And C minus 1 minus 2. This is minus 3. So, D ratios of the line 2, minus 1, 3. So, line passes through 0, 1, minus 2. So, we can write equation of line in symmetric form. X minus 0 by 2, y minus 1 by 1, z plus 2 by minus 3. This is 2. So, now it is simple. So, they are in standard form. So, shortest distance. So, shortest distance equals to x2 minus x1. So, x2 minus x1. So, this is 1, this 1, 0, 1 minus 1, 0. This is A. Another point is 0, 1 minus 2. So, x2 minus x1. So, this is 1. x1 minus x2. This one is minus 2. And this one is 2. But alpha minus 1, 1, 2, 1, minus 3 by root over. So, 3 minus 1 whole square. So, this is 2 square plus this one cancel. So, 2 plus 3 alpha whole square, and this one alpha plus 2 whole square equals to 1 by root 3. So, from this equation we have to find alpha. So, if we solve it, so 1 into 3 minus 1, this is 2, minus minus a plus, 2 into minus 3 alpha minus 2, minus 3 alpha minus 2 plus 2 into alpha plus 2 by root over. So, alpha square 9 alpha square. So, 10 alpha square. This is 12 alpha plus 4 alpha, 16 alpha, 16 alpha. This is 4, this is 4, 8, 8 plus 4, 12 equals to 1 by root 3. So, simplifying, look, 3 into, if we take square, 3 into minus 6 alpha plus 2 alpha. So, minus 4 alpha, 4 alpha, minus 4 cancel, plus 2 whole square equals to 10 alpha square plus 16 alpha plus 12. So, now, so 3 into expansion of this 16 alpha square minus 16 alpha plus 4 equals to 10 alpha square plus 16 alpha plus 12. So, 3 into 4, 12 is cancelled out. So, 6 alpha square minus 32 alpha equals to 0. So, alpha into 3 alpha minus 16 equals to 0. So, alpha equals to alpha 6, 16, and this is 32. So, 48, this is not 16, 48 minus 16, 48 minus 16. So, 32, 48 minus 10. So, 38 alpha square, 48 minus 10. So, alpha common. So, this is 19 alpha minus 16. So, alpha equals to 0, alpha equals to 16 by 19. Alpha equals to 0 and alpha equals to 16 by 19. So look it again. 16 into 3 minus 48, minus 48 minus 16, this is 64 alpha, I think. This is minus 48 minus 16, 64 alpha. So 19 alpha minus 32, 2 alpha common. So alpha equals to 0 and 32 by 19. So 32 by 19 is one value of alpha. So alpha not equals to 0 because it is. So one value of alpha is 32 by 19. So this is lengthy. So you put equation in symmetric form and use formula of shortest distance. Now we consider three same types of problem, 12, 13, 15 from description list. So problem number 13. So the angle between the lines this and this is given by this. So first line is given in this form, x minus 1 by 1, 2y plus 3 by 3, z plus 5 by 2. So to make it standard form, x minus 1 by 1, y plus 3 by 2 by 3 by 2. To make coefficient of 1, y, so z plus 5 by 2. So D ratios 1, 3 by 2, 2. That is 2, 3, 4. This is D ratios of the first line. Now second line is not given in standard form. It is given in parametric form. So R is parameter. So from the first x equals to 3r plus 2. So what is R? X minus 2 by 3. X minus 2 by 3. And y equals to minus 2r minus 1. So 2r equals to minus y minus 1. So r equals to y plus 1 by minus 2. So it is in symmetric form. If we write this is r, y plus 1 by minus 2, and look z equals to 2. We have already discussed it. If it is z by 2, so z equals to 2. So z minus 2 by 0. So you consider first and last, you get z equals to 2, first we get this. So this one is 2 and this one is 1. So what is D ratios? D ratios 3 minus 2, 0. So look A1, B1, A2, B2, A3, B3. So 2 into 3 plus 3 into minus 2 plus 4 into 0. So this is 0. So cos theta equals to 0. So theta equals to pi by 2. Theta equals to pi by 2. Cos theta equals to formula is this by root over a1 square b1 square, a1 square a2 square a3 square, b1 square b2 square a3 square. So this equals to 0. So angle is pi by 2. So option D is correct. So this one, so you put in standard form and find the angle. This is also problem of JEE Main. Now we consider two same types of problem, 11 and 14. A line L passing through origin and is perpendicular to the line L1 and L2. The coordinates of the points on L2 at a distance root over 17 unit from intersection of L and L1. So lines are not given in standard form. So L1, so we write it standard form. So 3i minus j plus 4k plus t into I plus 2j plus 2k. So if we consider in Cartesian form, then its equation is x minus 3, y plus 1, z minus 4, 1, 2, 2. So this is L1. L2 is 3i plus 3j plus 2k plus s into 2i plus 2z plus k. So it is in Cartesian form, x minus 3 by 2, y minus 3 by 2, z minus 2 by 1. So this is representation of L1 and L2 in standard form. Now a line passing through origin and perpendicular to L1, perpendicular to L1. So L1 and L2, they are in standard form. Now a line passing through origin. So point is given perpendicular to both L1 and L2. So equation of line. So let D ratios of L A, B, C. So it is perpendicular to first line. So A plus 2B plus 2C equals to 0. It is perpendicular to L2. So 2A plus 2B plus C equals to 0. So A by B by C by. So 2 minus 4. So this is minus 2. B. 4 minus 1. This is 3. 2 minus 4. This is minus 2. So D ratios is A by 2, B by minus 3, C by 2. So what is L? What is the line L? So L is passing through origin. So x by 2, y by minus 3, z by 2. So this is our first phase. A line passing through origin and perpendicular to L1 and L2. This one is L. So we are getting L. Next we have to find the coordinates of the point on L2 at a distance root 17 unit from intersection of L1 and L2. So we have to find intersection of L1 and L2. So L and L1. So this equals to K. So any point on L is 2K minus 3K, 2K. Any point on L. So intersection of L and L1. So putting x equals to 2K, y equals to minus 3K and z equals to 2K. To find points of intersection, so we put value of x, y, z in L1. So 2K minus 3 by 1, minus 3K plus 1 by 2, 2K minus 4 by 2. So if we consider first 2, so 4K minus 6 equals to minus 3K plus 1. So 7K equals to 7. So K equals to 1. And you look, you are getting same to second and third. So minus 6K plus 2 equals to 4K minus 8. So minus 6K plus 2 equals to 4K minus 8. So 10 equals to 10K. So K equals to 1. Therefore two lines intersect. We are getting same K. What is the point of intersection? So point of intersection is So 2 minus 3, 2. So this is point of intersection. So this is second phase of the problem. Now third one. Now you have to find point on L2. Take a point on L2. Suppose this equals to lambda. So any point on L2. Any point on L2. So this is lambda plus 3. 2 lambda minus 1. 2 lambda plus 4. So lambda plus 3. 2 lambda minus 1. And 2 lambda plus 4. So coordinates of points on L2 at a distance root 17 unit from intersection of L and L1. So this is suppose P, and point of intersection, suppose this is Q, 2 minus 3, 2. So it is given PQ equals to root over 17. So PQ equals to root over 17. So solve this equation. So what is PQ? Lambda minus 1 whole square plus 2 lambda plus 2 whole square and plus 2 lambda plus 2 whole square equals to 17. So any point on L2, this is L2, this one is lambda, this is L1, this is L1, this is L2. So point will be 2 lambda plus 3, this one also 2 lambda plus 3, and this is lambda plus 2, lambda plus 2, any point of L2. So now we find distance of P and Q. So PQ equals to PQ square equals to 17. PQ square equals to 17. This implies this minus this. So 2 lambda plus 1 whole square. 2 lambda plus 1 whole square. Plus 2 lambda plus 6 whole square. 2 lambda plus 6 whole square. Plus lambda square equals to 17. Equals to 17. So expanding 4 lambda square plus 4 lambda plus 1, 4 lambda square plus 24 lambda plus 36 plus lambda square equals to 17. Now 4 lambda square, 8 lambda square, 9 lambda square, 24, 28, 24 and this 28 lambda, and this is 37 minus 17. So 20 plus 20 equals to 0. So 180, 9 lambda square, 18 lambda plus 10 lambda plus 20 equals to 0. So 9 lambda common, lambda plus 2 plus 10 common, lambda plus 2 equals to 0. So lambda plus 2 into 9 lambda plus 10 equals to 0. So lambda equals to minus 2 and minus 10 by 9. So this is very lengthy also. So we get lambda. So putting lambda equals to minus 2, lambda equals to minus 2, we get 1. Lambda equals to minus 2, so minus 4 plus 3, 1 point is minus 1. So this is minus 1. And lambda equals to minus 2, this one is 0. This one is 0. Lambda plus 2. So lambda equals to minus 2. So this is 1 point. And putting value of lambda equals to this, we get other point. So you solve rest of the problem from description list. Today we have discussed straight line, its different form, angle between two straight lines, coplanar lines, shortest distance between two straight lines, and condition of coplanarity of two lines. So I think this problem will help you to get 4 marks problem from 3-dimensional geometry.